Hey, what's up, guys? So, today we are going to solve this challenge called Desires from Hack the Box, and I'm going to do a complete solution walkthrough of it. So, what that essentially means is that I'm going to take you from briefly explaining the problem description to how to actually approach it and how to do taint analysis, which is like basically a smarter way of analyzing source code in these challenges, and how to actually like what was going on in my mind when I was solving this challenge to finally like how you could actually solve it. But there's a little bit of disclaimer here. First of all, of course, this is for educational purposes. But secondly, if you're somebody who just wants the final script, that they could just simply run a script and then just simply get the flag and submit it. Or if you're somebody who just wants the flag, no hard work, right? So if you're somebody like that, then this video is not for you, because I am not going to reveal the source code for my script, or I am not going to reveal the flag. So if you are here because of that reason, then I'm sorry, this is not for you. But if you're somebody who tried this challenge once and you got stuck on some part, or you felt that maybe this challenge is too difficult, or I don't understand a certain aspect of it, then you can watch this video, right? By the way, this challenge is rated easy on HackTheBox. Let me just show that to you. Yeah, so this is rated easy, but don't like get disappointed if you can't really solve it all by yourself in the first go. Yeah, as you can see, because this is a slightly trickier challenge. If you don't actually are not actually aware about a lot of these things like race conditions, which we will see in this challenge further, right? Okay, so that was a lot of introduction. Now let's get started. So I have started this challenge on my local host right here using Docker. You could also use the hack the box server to do that. And here I have the source code. Okay, so the first thing obviously is that you will just like unzip the source code file that you got, and you start looking at a few files like this Docker file, right? And these files are pretty standard, but it's good to read it. So you notice some things like Go is being used and Node is being used somewhere, right? But most importantly, you have to realize that there's this environment variable called flag, which is HDB and then bracket redacted, right? So now you have an idea that the actual flag is not somewhere in the file system, but it's actually in the environment variables, and you basically kind of need to access it from here, right? Then you could maybe read this build docker.sh file, doesn't do much. And then there is the config folders. There's a solution folder, but that is my solution. I made it, right? Uh, wouldn't be present in your files, but there's this config folder with this supervisor config, right? You can read this if you want, right? But nothing too much here, right? And then we have this challenge folder with the actual challenge files. So there are two folders, service and SSO. In SSO we have some SQLite stuff, so registering a user and then logging in and stuff, right? Okay. And but basically the main part, the actual relevant part of the challenge is in this service folder, and you start looking at main.go. You read through this code, you see, okay, so under static folder, all files are served statically, and then these are some routes mapped to some services or route handlers, as you can call it, right? And then these are some authenticated groups. So for example, there is a slash upload and there's a slash admin, and then maybe you can go a little bit around the website here. So for example, you could just log in. For example, I'm just logging in as normal and then normal, right? Register, and then you can log in. And then when you log in, you get this page, right? And it says upload archives for desires. So first of all, you could maybe try uploading any kind of file here, right? But when you, in the end, you will realize that you have to actually submit a zip file here. So for example, if I just take a random zip file here, dist.zip, and I just upload it, it says archive uploaded and extracted successfully, right? So um, this functionality should give a hint that it's something to related with the something to do with this, extraction service. Now the next thing, which you may think is that, okay, so if I am uploading archive and it's actually getting extracted on the server, maybe I could get RCE of some sort, right? Maybe I could like upload a malicious zip and it has a reverse shell PHP, basic web shell, right, and PHP written in it, and maybe I could access it. But you will find out that it wouldn't work because this server is running on a pre-compiled Go binary, right? And it does not support PHP, so PHP won't work. You might think of any other ways to get RCE, but you would realize that none of those would work, right? So after dwelling a little bit into the source code, you will realize that okay, I have under this services folder http.go, and if you take a look at these functions, these are pretty normal. So upload enigma and so on. And there's this function called desire is enigma. And what it does is that it basically, first of all, it fetches the user, right? And if it checks if the user's role is admin, and if it is admin, then it just simply just renders the admin page with the flag. So our goal here is to access the admin user, is to become an admin user on the server, right? So how can we do that? After a little bit more analysis, you in the end you know that you need to do something with extraction, right? So you should start looking at the uploading the file and extracting it logic. So this is the logic upload enigma, and basically what's happening is that it's taking the file name and generating a new UUID and just renaming the file to some random gibberish UUID plus the file extension, and then just saving it in this uploads folder, right? You might think that there could be path traversal here, so maybe we could upload a zip archive and name it something like dot dot slash dot dot slash dot dot slash, so that it actually gets stored into the root folder, right? And then when it is extracted, then we have placed a file into the root folder. Maybe we could do something like that, but that won't work as well because the file name is getting saved as a UUID plus the extension, right? So for example, what I could do here is that I could take a look at the so I could just get a shell on my Docker machine and see what's happening, right? So now I have a shell. I could go to service, and if I zoom in, so this is the files folder, and then normal, which is my username, and this is the dist file, right? But uh, even though, let's try to just upload a random file and you will see what I'm trying to see. So something like let's say file, upload this, and it says unrecognized by file name, upload slash this random gibberish, right? Because this is what it's getting stored as. So it doesn't really matter if you were to attempt a path traversal here, because your file name is getting replaced by this UUID anyways, right? So that's not something we can do here, right? Then you see this unarchive function, right? Archiver.unarchive, and you see what this archiver variable holds, and you find out that this archiver is basically imported from this GitHub, sorry, this Go module here, right? So what you can do is you can go to go.mod and check out the version of this archiver. And um, one obvious thing is that you could try to see if there are any known vulnerabilities in this version. So you could uh, go and Google for archiver and maybe something like vulnerabilities, right? You can Google for this and you find out that there is something called vulnerable to path traversal and stuff. So you open it and you see, okay, there's a path traversal vulnerability here. And okay, so where is the version here? maybe somewhere here. Okay, so here's where the stuff is. So CVE part traversal vulnerability, and it says that that's only if using 3.51.1, right? 3.5.2 is good. And then you can check the version and you can realize that this is 3.5.0. This means that this archiver is vulnerable to this path traversal. And then you can maybe search if there are any public CVEs, sorry, or POCs, right? And you find it. So CVE POC using symlinks. Somebody has made a POC, and you can basically like just check the script. um, he has made this pretty detailed, so you could just copy it and create a zip archive, or sorry, a tar archive with which has symlinks to other paths. And what happens is that the tar archive contains symlinks to arbitrary paths, so when it is extracted on the system, it writes the file to the path that is pointed by the symlink. So the file is extracted to any arbitrary location, right? And so you could use this vulnerability to extract a file to any arbitrary location, right? Next thing what you have to pay attention to is you have to understand how the sessions or the authentication mechanism is working, right? So let's take a look at http.go, and let's take a look at what it takes to be an admin. So, mm, where's the session? Okay, this is the session middleware. So it gets the session ID from the session cookie, username from the user cookie, and then the get session function is run. And in the get session function, it says that user session ID is just utils.redis-client.get via the username. So redis-client.get, and it's basically okay. So what's happening over here is that there is this prepare session function, right? And what this is doing is that it's taking a session ID and a username, and it's simply setting that key value pair username comma session ID into the Redis store. It's using Redis, right? And when you're this is actually happening when you're logging in. So when you're logging in with, for example, normal and normal username and password, a session ID is generated for you, and the value key value pair username, which is normal, and the session ID that was just generated is stored into the Redis storage, right? And then when you actually like request any authenticated route, right, then your session ID under your username is sent, and that username is taken, and it is used to query the Redis store for a session ID, right? Then it gets that session ID, and what it does is that it reads this the following file. So slash tmp slash sessions username session ID, right? So let's say uh, your username, let me just zoom in this. Okay, so let's say your username is normal and your session ID is 1234, right? So the file is read from sessions slash normal slash 1234. This is where the file is read from. And if you do further source code analysis, then you will find out that the file that is written is somewhere in this form. So you can read the admin struct, and it's something like this. So it's like username, normal, um, ID one, and then a role, right, which is user. So it's something like this, right? So this JSON data is read from this file, and then this object is returned to you. Now, what you could do with this path traversal vulnerability that CVE you found in the archiver is that you could maybe modify this file. So you could, let's say that you are preparing a malicious.tar file, right? And then you could uh, have a file with a content like username, normal. ID 1 role admin, right? You can have a file like this and symlink this to this path, sessions normal 1234. You already know your username. You already also know your session ID because it's in your local storage or the cookies, right? It's in your cookies, right? So you know this file. So you could generate a file with this content and symlink it to this path, right? And then just store the file in this malicious.tar, and you could upload it to the server, right? And then when it is extracted, right? When it's extracted, then this file is placed into this normal slash 1234, and the content should be overwritten. So this should be the new content, right? And then when the then when you take an authenticated request to, let's say you visit slash admin, and then what does the system do? It takes your username, which is normal, right? Gets its session ID, which results in a 1234, right? Then it reads this file normal slash session ID, and this is the content that is stored in this file. So this exact content is then served to you, right? So then basically you get admin, and then you could visit this admin endpoint, right? So this is one thinking that you might have, and when you try it, you will find out that you get errors like, if you try it, then you will find out, then you will get errors like file already exists. You will get these errors. Now, why is that? Well, that's because by default, when in Archiver, the tar or the zip file or any archive that you upload, if that archive contains a file which already exists on the file system, then it would lead to a collision. It won't replace that file. It would lead to a collision, and it would throw an error like file already exists. And that is what prevents you from overriding any session files, right? And now this is where most people are getting stuck in this challenge, right? So if you are also somebody who got stuck here, now let me reveal to you what is the final blow here, right? Okay, so if you were to analyze this source code more carefully, then somewhere in, let me see, uh, there was a file which was responsible for generating sessions. Yeah, sorry, this one. So create session function. If you take a closer um, look at this, then wait, is this it? Hmm, this is not the file. Redis response HTTP. Yeah, over here. So in the login handler function, you see this is how the session ID is being generated. What it's doing is that string conversion format in time.now, so the current time, converted to a Unix timestamp, and then converted to a base 10 string, right? And then that Unix timestamp is hashed via SHA-256, right? And this is vulnerable to insecure randomness, right? So basically what the server is doing, it's that it's taking the current time, converting it to a Unix timestamp, right, and hashing it via SHA-256. Now if you could get your hands on this current time, right, or this Unix timestamp, can you not just hash that same thing and get the final session ID? So you can, if you have the timestamp of the server, then you could predict future session IDs, right? And now the question is, but how will we get the timestamp or the current time of the server? Um, Now, if you observe carefully here, let me just go to the home page, and if you inspect it a little bit, network, if you reload it, this GET request, in the response headers, you have this date header, right? Which is basically the time at which this response was served. You could convert this into a Unix timestamp, and you now have the timestamp or the exact time where when the server served the request. And so you could generate future session IDs via this mechanism. You could simply write a function that does it for you. Okay, but how is it any useful? Right. Now, this is what I'm about to tell you. This is like a difficult scenario if you are doing it for the very first time, but just understand carefully what I'm trying to say. Okay, so uh, when a user logs in, right, with a username and a password. Username, let's say normal, and password, let's say normal, right? What happens in the backend? First of all, a session ID is generated, right? Yes. First of all, a session ID is generated. What happens after that? That session ID is, if I am not mistaken, uh, let me just show it to you over here. Right. So a session is prepared, yeah. So when a user logs in with a username and a password, a session ID is generated via the same SHA-50, hashing the current timestamp method, and his session is prepared in the Redis storage, right? And then when the user makes authenticated request, his username is taken, the session is fetched, and then the session is used to query the file and just get the JSON data. Uh, Now, what if you could predict future session IDs, right? And you could send a login request. You have already predicted the future session ID that the login function is going to create, right? And um, before the actual login function writes to the session ID file, you write it yourself, right? Using that tar upload functionality, right? So just pay very close attention to this, right? You hit the slash login endpoint with username equals to normal and password equals to normal, right? You have in advance generated a valid session ID, right? Let's say 56747. This is a valid session ID that you have generated in advance using that date header, right? Now the login function is going to generate the same session ID 5647, right? And then it is going to prepare session, which is basically writing normal comma this session ID 5647 to Redis storage, right? After that, it is going to write to file slash tmp slash sessions slash normal slash 5647, right? And it's going to write the following data: username normal and id 1, and let's say, sorry, role to be user because you have logged in normally, right? And it's going to write this data. Okay, so you already predicted this, right? So what if you could create such a race condition which, when the login route has done this second step, so generating the session ID, this is the first step, preparing the session, this is the second step, and writing to the file, this is the third step. What if you could create such a race condition that when the login function has executed the second step and it is going to execute the third step, in between, if you could create another request which uploads the malicious tar archive, right? And the tar archive does the following. It writes to /tmp/sessions/normal slash your generated or your predicted session ID, and it writes the following malicious data: username normal, and then ID to be 1, and then role to be admin. You can write this data, and this data would be successfully written because this entire file does not exist on the file system yet. It is about to be written to the file system by the login function. But my assumption is that you are creating such a race condition, such a delicate race condition, that it does this whole process between the steps 2 and 3, right? It writes to this file system, and then it tries to access the admin endpoint. What will happen if you try to access the admin endpoint between these steps 2 and 3, right? It would take your username is normal, right? It would get the session ID associated with this username. This session ID has already been set into the Redis storage, which is this. So you will get, for the normal username, you would get this session ID, right? And then this file um, would be queried. So the server will try to read this file, right? And this is the actual data which is present in this file. So the role of admin is read, and then you are actually given access to the admin file, right? Then you could just get the admin file actually, and then you could just uh, fetch the flag directly, right? Let me just repeat it once again. Exact steps you have to do. What I will do now is I will just create this stuff formally in a separate tab. So now I'm writing exactly what you need to do, right? First of all, send a request to the normal slash endpoint, right? Read the date response header and generate a valid session ID, uh, generate a session ID which should be valid after, let's say, 3 seconds, right? Now what you need to do is that send a request to slash login endpoint, right? At the same time as step 3, right? Also let me just, I will create another step here. So step 3, what you need to do after you have predicted the valid session ID in the future after 3 seconds is create a malicious tar which contains a symlink to slash tmp slash sessions slash your username, right, slash this predicted session ID, right, with the admin JSON, right? Now step 4 is that after 3 seconds have passed, send a request to login endpoint, and at the same time as step 3. So these requests in step 4 and 5, they have to be sent at the same time. So at the same time as step 4, send a request to upload the malicious tar archive and extract it. The server will do it for you, right? And right, um, then send a request to slash admin, right? Now this is everything you need to do in order to solve this challenge, right? It should be pretty clear by now, but simply you just send a dummy request to slash endpoint to just get the date response header, so that you could generate a valid session ID which is valid after, let's say, 3 seconds. Then you create a malicious star which contains a symlink to this slash session slash your username and this um, predicted session ID with the admin JSON. So username normal, ID one, and then role to be admin, right? And then when 3 seconds have passed, just make your code sleep for 3 seconds after these 1 2 3 steps are done. When 3 seconds have passed, you need to send, or you need to run two functions parallelly, right? Simultaneously, concurrently, right? First function which simply sends a request to the login endpoint, and the second function which first sends a request to upload the malicious star archive, right? Which will be extracted, and the data would be written, and then a request to admin, right? And you will need to repeat this process like 5 or 6 times maybe, and then when a race condition occurs, you will finally be able to read the uh, file, right, the admin file, and you will finally get the flag. I have done this process. The file is available in my solution folder, so script.file, script.py, but I can't really show it because for the same reasons that I said earlier. But basically, this is the entire procedure that you need to follow, right? If you actually like, if you don't understand something in this problem, or if you face any difficulty, you can post into my comment section, and I will try to like post the solution or the entire script once the um, challenge is expired, or sorry, not expired, just retired, right? I will try to do that, and that is basically what the challenge is about. Another thing, another interesting thing over here is that you might notice that in the authentication middleware, right? Uh, what it's simply doing is that it's extracting the username, and it's getting the session ID corresponding to that username, and then it's reading that, right? So that does mean that account takeover is fully possible, but if you think about it, then it is possible in theory. So account takeover is possible. So it is a bad practice, but you can't really exploit it in this scenario to solve the CTF challenge, because there is no by default admin user registered, right? There is no admin user in the system, so you have to create an admin user and then you need to access it, right? So this is one thing, and another very interesting thing is that you have after doing all of this procedure and getting access to admin, you have access to the admin endpoint for a very minimal time, right? Because of the race condition, you have access to the endpoint at for a very minimal, let's say half a second or 1 second, because when the login function completes its entire execution, then the session file is already overwritten with the normal user data. So if you would try to reload the page and access admin again, you will get a forbidden error because the session file has been overwritten, right? So this is another very special thing about this challenge, right? So that was the entire solution. I hope I did a decent job at explaining the solution. Again, if you have any doubts, then you could just post it into the comments. And that was it. See you in another write-up or walkthrough.